Here in this question, matrix A is given as 2 4 1 2 and A power 4 is given as n into A, and we have to find the value of n. Matrix A is given as 2 4 1 2. If you find A square, you would be getting as 8 16 4 8, which is equal to 4 into 2 4 1 2. This is nothing but 4 into A. So we got A square as 4A. We have to find A power 4. So here A power 4 is equal to A square into A square whole square. This is nothing but 4A whole square. This is nothing but 16 into A square. If we substitute A square as 4 into A, 16 into A square as 4 into A, you would be getting A power 4 as 64A. So here n is nothing but 64, which is equal to 2 power 6. So here correct option is option D. Here in this question, the algebraic structure with set G and operation star is given, and operation star is defined as A star B is equal to A square into B. So star is defined as A star B is equal to A square into B, and we have to find and group and set G contains all the real numbers except 0. So and we have to find the nature of the algebraic structure. That is, we have to find if it is a monoid, a semigroup, or a group. Here star operation is closure. Here star operation is closed. Why? Because if we perform star operation between any pair of elements, the result will belong to the given set G. So star operation is closed. Hence it is groupoid. Let us check if star holds associative property or not. Let us consider A star B star C. So this would be equal to A power 4 B square C, and A star B star C is equal to A square B square C. So here A star B star C is not equal to A star B star C. So here associative property is not satisfied. So this is not a semigroup. If it is not a semigroup, it is not a monoid and it is not a group. So here just closure property is satisfied. So we can say this is just a groupoid. So here the correct option is option A.
Certain function f has the following truth table. That is, truth table is given like this: a 3 variable function ABC, 0 0 0 output is 1, 0 0 1 output is 0, something like that, 1 1 1 output is 1. What is the minimum number of 2 input NAND gates required to implement the function in minimal sum of product expression if variables are available in both primed and non-primed format? So we need to find out the minimum number of NAND gates required in minimal sum of products format. So first of all, for this we have to find out minimal sum of products format for this. So this is a common data question. There are 2 questions based on this data. So the question number 1 is given like this: what is the minimum number of 2 input NAND gates required. First of all, we have to find out sum of products format for this. So we have to take the Karnaugh method for simplifying the above truth table, the Boolean function, that is, for example, these are given in ABC format. So 0 0 0 1 1 0 1 1 0 1. The minterms producing one are 0 3 4 5 and 7. 1 0 1 2 3 4 5 6 and 7. So these are the minterms producing ones. So the correct mapping for this is these two can be mapped, these two can be mapped, and these two can be mapped. So from this, the expression, minimum expression is B dash C dash plus BC plus AC from this format, from this K-map method. So here this can be represented by means of some NAND gate representation. That is, first you take B dash C dash, take in the NAND gate, and again take BC, the NAND gate. So these two again you have to take into NAND. This can be given into two inputs again through NAND gate. Again you have to take AC also into NAND gate. So these two must be given to another NAND gate. So this will produce this F. That is, here we get a B dash C dash whole dash, that is B plus C you get here. From here we get B plus C whole dash is B dash plus C dash. So from this you get AC whole dash. So here B plus C and B dash plus C dash. So this and this NAND gate will represent B dash C dash plus BC plus AC. So this is 1 2 3 4 5 6 NAND gates are required. Option C is the right option. So there is another question on this same data. If the function f, that is we have defined above, is implemented using 4 input multiplexer, then determine input I1 of the multiplexer. So we are defining with this 4 input multiplexer. Usually the 4 input multiplexer will be like this. That is I0, I1, I2, I3 are the inputs. So what inputs we have to give in order to get the output F, and the selection lines let it be some A comma B for example. So output F, the F is given as B dash C dash plus BC plus AC. So here if you want to get this output, you would have this I0 C dash, I1 C, I2 1 and I3 C. So I1, input I1 should be equal to C. So option C is the right option here.